Welcome to the deep dive. This is where we take those dense sources, all that research, and really boil it down to the key knowledge you need.
Yeah, distilling the high-impact stuff.
Exactly. And today we're diving into something pretty fundamental for managing resources sustainably: data collection.
Mm-hmm.
Specifically, we're looking at how science helped improve, well, the basic administrative foundation for tracking small-scale fisheries down in Mexico.
Right, and we're focusing on this short communication paper. It's titled Data Collection on the Small-Scale Fisheries of Mexico,
Okay.
published back in 2011 in the ICS Journal of Marine Science. The lead author was Mauricio Ramírez-Rodríguez.
And what's so interesting about this particular paper?
Well, it details the progress they made adapting Mexico's official fishery information system. It's called SAROPA, basically making it fit for purpose for small-scale operations.
Right. So our mission here is to really understand how this bureaucratic overhaul, sounds dry maybe, but how it actually allowed managers to finally get a handle on what this huge small-scale fishing fleet was actually doing.
And the stakes are really high here.
Mm.
I mean, effective fishery management, it has to be based on an ecological framework, right?
Absolutely.
Which means you need solid, reliable information on the resources, the environment, the fleets, the markets, even policy impacts. If that base data is shaky, well, you're essentially flying blind trying to protect anything.
And let's give you a sense of the scale here. We're talking about Mexican small-scale fisheries. Those are vessels under 10 gross registered tons.
Tiny boats, relatively speaking.
Right, but this isn't some small niche activity. It's massive. In 2008, the system recorded, get this, 102,807 boats in just this sector.
Wow.
Yeah. And they're catching everything: coastal, finfish, sharks, crustaceans, mollusks, echinoderms, trying to track the movements and catch of, over 100,000 unique boats.
Sure.
That's an administrative Everest.
It really is. And that brings us straight to the core problem they faced. The data, or rather the data quality.
Okay.
So the raw material for basically all Mexican fisheries statistics comes from just one main source, this form called the Notice of Arrival for vessels under 10T.
We'd probably just call it a trip ticket, right?
Exactly, a trip ticket. It's a weekly report filed by the economic unit manager. Supposedly it notes the vessels, the gear they used, the catch per species, where they fished and landed, and the bait.
Okay, that sounds pretty logical on paper. So where did it fall down?
The big constraint was the codes. The existing codes Coropropi used for fishing sites and for species were just too general. They didn't allow for any meaningful spatial analysis. You sort of knew when something landed and maybe what it was broadly, but you couldn't easily integrate that data by specific fishing zone.
So you couldn't track fleet behavior or see if one area was getting hit harder than another?
Precisely. That lack of spatial detail just stopped any effective analysis of fleet movement or, the dynamics of resource depletion in specific spots.
But hang on, enforcing a spatial fix. I mean, fishing vessels move around constantly. Isn't mapping and coordinating thousands of landing sites, then making sure people use the right codes for those locations? Isn't that a huge administrative headache?
Oh, it's a significant challenge, absolutely.
Yeah.
But they started by focusing on making the data usable first. The geographical fix, the where, involved creating tools based on GIS principles, Geographic Information Systems.
Right.
So they developed this thing called the Atlas of Mexican Fishing Sites. Essentially, it assigned proper latitude and longitude coordinates to all the known fishing and landing sites.
Okay, putting them on the map properly.
Exactly. And crucially, they organized these locations following a standard north to south order. This fixed the old system, which, believe it or not, lacked any formal geographic criteria at all. They turned these vague descriptions into actual precise points on a map.
Okay, so the where gets fixed with GIS and the Atlas. Then they had to tackle the species identification. And you mentioned this is complex because of language and local name.
Oh, extremely complex. You've got fishers using traditional names, local names, regional names, names that have been used for decades, maybe centuries, for this huge number of species they exploit.
So one person's red snapper is another person's para, maybe?
Exactly. Or a name that only people in one specific bay even recognize. When that hits a centralized database, well, it just becomes chaos. Confusion reigns.
So what was the fix for that?
They proposed this really innovative species identification code, a pretty rigorous 8-digit system specifically designed to standardize the information and define the level you could integrate it at.
An 8-digit code. How does that work? What does it capture?
Well, the structure is quite clever. It gives you analytical power. The first two digits tell you the broad taxonomic level, like is it algae, is it fish?
Okay.
The next two define the type of species, maybe demersal, living near the bottom, or pelagic, out in the water column.
Right.
Then two digits for the commercial category or the family. So, snapper is the Legenidae family.
Got it.
And the final two digits nail down the specific species linked to both scientific and common names.
That segmented structure sounds really useful.
It is. It's key for policy flexibility. Take their example code, 08012501. You can instantly see 08 means fish. 01 means demersal fish. 25 is the snapper family pargos. And 01 is a specific species, Hubbalpagrus glentheri, the Mexican barred snapper.
So you can manage at different levels.
Exactly. Policymakers can look at the whole snapper family group if they need to, just using the first 6 digits for aggregation. Or if one particular species is in trouble, they can regulate just that one using all 8 digits. It gives them options instantly, depending on the conservation need.
That is a massive breakthrough. And the paper notes this new system links up with other codes too, like international ones.
Yes, it correlates these new catalog codes with other national and international systems, like the FAO Alpha 3 code.
Ah, the FAO Alpha 3. For listeners, that's the sort of standard international shorthand for species. So this makes the Mexican data immediately usable for wider scientific collaboration. That's huge.
Absolutely. And to show just how powerful these new coded data points were, they included a case study, Baja California Sur, BCS.
BCS, that's a major fishing area, right?
Yeah.
Very complex.
Hugely important. Ranks 3rd in the country for production, averaging over, 136,000 tons a year back then? In 2009, it had nearly 5,000 small-scale vessels operating.
So why was it the perfect testing ground for this new system?
Well, because of that complexity you mentioned. If the new spatial and taxonomic system could bring clarity to a place like BCS, with all its diverse fisheries, it could likely work anywhere in Mexico.
Makes sense.
So the analysis focused on one specific area within BCS, Bahia Magdalena BMA. They used the new codes to figure out the relative importance of 14 different fisheries there over a 10-year period, 1998 to 2009.
And what did that reveal? Did it confirm existing knowledge or uncover new things?
Both, really. But the new data immediately captured some crucial economic nuances that were previously obscured.
Like what?
Well, the Pacific scallop fishery really stood out. It dominated the catch weight, 51% of the total landings by weight, and it also accounted for about a third, 33% of the total value. So big volume, big value.
Okay, that seems logical. But you mentioned nuance.
Right, look at shrimp. Shrimp catches were only about 4% of the quantity landed. Tiny fraction compared to scallops.
Okay.
But that 4% accounted for a massive 25% of the total economic value from those 14 fisheries.
Wow, okay. Low volume, super high value.
Exactly. And having the data system distinguish that high volume, maybe lower value commodities versus low volume, high value, catches that kind of insight, tells authorities precisely where the economic vulnerability lies, and perhaps where to focus high value protection or targeted conservation efforts. It's strategic information.
That really shows the power of getting the basic data structure right. Let's dive deeper then. You mentioned monitoring fleet behavior. Can we use the black arc fishery as an example? Anodara tuberculosa.
Yeah, the black arc in BMA is a perfect concrete example of how they applied this new system to track what the fishes were actually doing over time in space.
Okay, what did the data show there?
Well, the macro picture, just looking at total landings, showed a pretty stark trend. Catches dropped significantly, from around 650 tons in 1999 down to just 280 tons by 2008.
That's more than half gone in less than a decade. Worrying.
Very worrying. But the new GIS-enabled system, with those specific spatial codes, allowed them to drill down much deeper than just the overall total. It provided the mechanism for understanding how that decline happened spatially.
And how quickly could policymakers react to this more granular data compared to just knowing the total catch was falling?
Well, the speed is really in the diagnosis. The old system might just show the total decline, maybe triggering alarm bells eventually. But the new analysis identified 10 distinct fishing zones. They labeled them Z1 through Z10 that the black arc fishers were using within Bahia Magdalena.
Okay, 10 zones.
And here's the crucial finding. The fleet's behavior wasn't uniform across those zones. 7 out of the 10 zones showed a clear declining annual catch per vessel between 1998 and 2007.
So fishers were experiencing diminishing returns in most areas.
Yes. It suggests they were dynamically abandoning zones as they became depleted. Interestingly, only one zone, Zone 9, actually showed an increase in catch per vessel.
Suggesting effort was maybe being redirected there?
That's a strong possibility. That spatial revelation is key. It means management can finally move beyond really simple, blunt instruments, like closing the entire bay, maybe.
Right, which would be inefficient and probably anger a lot of fishers.
Absolutely. Because the black arc, it takes about 1.5 to 3 years to reach maturity. Knowing that and having this spatial data showing depletion trends in specific zones, well, it supports much more targeted management, like rotational closures.
So you could close, say, those 7 declining zones.
Exactly. Authorities could propose closing specific areas based on the observed depletion trends and the known time needed for the arc to recover, rather than implementing a blanket restriction across the entire bay that harms the still productive areas, like Zone 9, unnecessarily.
And that seems to be the real novelty here, showing how fixing these, frankly, kind of boring administrative inputs like location codes
Yeah, getting the plumbing right.
leads directly to the possibility of sophisticated, dynamic, area-specific management plans.
Precisely. Which brings us to the broader implications, but also, importantly, the limitations the paper points out.
Okay.
So the system clearly works. It generates reliable, spatially defined data, useful for performance indicators on production, fishing zones, seasons. It allows for applying various assessment methods. It's powerful.
But there's a but.
There's a big but. The paper is very honest about a major remaining gap. There's still very little factual information on actual fishing effort.
Okay, define fishing effort in this context. What exactly does that mean we're missing?
Effort means the real intensity of the fishing activity. So not just that they fished, but the actual hours or days the boats spent actively fishing. What specific gear did they deploy? How efficiently were they using it? Things like that.
Right.
Now, the paper mentions that effort is currently sort of assumed to be stable, mainly because there are restrictions on issuing new fishing licenses.
Okay, so fewer new boats means stable effort.
That's the assumption. But it's a big assumption. The data they had, even with the improvements, was still insufficient to provide absolute production figures, or to really confirm the total pressure on the ecosystem with certainty. You don't know if the existing boats are fishing harder, for example.
And that underlying data quality challenge still persists, right? The whole system depends on accurate input.
Absolutely. The utility of all these refined indicators, the atlas, the 8-digit species code, it all hinges entirely on the quality and accuracy of the data recorded on those original trip tickets back at the landing site.
So if the manager filling out the form enters the wrong code for the zone or the species?
The whole analysis chain downstream can break down or at least become inaccurate. Garbage in, garbage out, basically.
So looking ahead, what are the next steps? Where does the research need to go?
Well, the paper points directly towards needing to investigate the interactions between fisheries. We need to understand the ecosystem overlap better. Meaning, for instance, how does the shifting activity of the black arc fleet, as they move between zones, impact maybe a clam fishery that exists in the same areas?
Ah, the knock-on effects.
Exactly. Proper integrated ecosystem-based management requires understanding those overlaps, those interactions. The improved system is only just beginning to make that possible.
And there's one final piece, isn't there? The human element.
Yes, absolutely crucial. The authors stress that you really need to supplement all this administrative data coming from the trip tickets with actual field work. And importantly, field work that's supported by the fishers themselves.
Getting local knowledge involved.
Right. Strengthening co-management, getting fishers involved and participating should hopefully translate into better quality data, more comprehensive data too. It's about merging these rigorous administrative tools with local ecological knowledge to actually validate the trends and the point estimates the computer models are showing.
So this deep dive really demonstrates that sometimes the most powerful management solutions come from fixing the seemingly mundane, the basic bureaucratic building blocks.
Absolutely.
Getting the latitude right, standardizing the names, implementing logical 8-digit codes, that groundwork, that plumbing, gives policymakers the real flexibility to manage anything from an entire species family down to a single recovery zone within a bay.
It does. This system, as developed, successfully tracks the changes in fleet behavior. It shows where fishers are concentrating effort or where they're abandoning resources.
Yeah.
That's incredibly valuable.
Right.
The big challenge remains defining the actual total intensity of ecosystem. Use that effort question again. And this raises a really interesting question for you, the listener, to think about. Okay, the data might tell us that Zone 7 is recovering naturally because fishers have moved away. Great. But what complex policy steps have to follow to make sure that the moment that zone reopens, fishing effort doesn't just flood back in and immediately destroy the recovery that happened?
Yeah.
The data is the vital first step, for sure. But the policy, informed by that data,
Yeah.
that's the really hard part.
That's an excellent point for us all to mull over. The data enables, but doesn't dictate, the solution. Well, thank you for joining us for this deep dive into the evolution of data collection in Mexico's vital small scale fisheries.